All right, so example 11.2.2, chi-square goodness of fit test. So let's look at one where we're actually like collecting, data from some, industry or place of business or something versus like rolling a die. So you're in charge of quality control at Mars Incorporated. If everything is working properly, the distribution of colors for M&Ms is given in the table 11.2.2 below. Okay, so we've got colors brown, yellow, red, blue, orange, and green. And if everything is working correctly, the percentage in each category would be 13%, 14%, 13, 24, 20, and 16. Okay, so we notice that they are not producing an equal percentage of all colors of M&Ms. Okay, so within here, the packages of M&Ms have a lot more blue ones, or at least they're supposed to if things are going correctly, than like brown ones. So they take a random sample, and the number of M&Ms was recorded for each color as shown in table 11.2.3 below. And we want to know if these results differ from the hypothesized distribution, and they've asked us to use a 0.10 level of significance. So again, there is no parameter in this type of problem, which means our hypothesis also does not have a parameter, but it's got a lot of words. So in this case, for the chi-square goodness of fit test, we're going to talk about the distribution, and in this case it's the distribution of colors. So the distribution of colors of M&Ms is the same, or consistent with, as what was stated by Mars, versus the distribution of colors of M&Ms is not the same, or is inconsistent with what was stated by Mars. So if we check the assumptions for the hypothesis test, in this case it says that they took a random sample of M&Ms. And if we actually add all those up, we get 820. So a random sample of 820 M&Ms was taken. And so the second step to get these expected frequencies for each cell, again, we need each of those to be greater than or equal to 5. And in this case, we don't expect the same count in each cell, so we're going to have to make some separate computations here. So the expected frequency for brown, we expect 13% of those 820 to be brown. So we're going to take 0.13 times 820, and that gives us 106.6. For yellow, we expect 14% of 820, and so that would be 114.8. Let's see, red is also 13%, so same as brown, so we would also expect 106.6. Blue, they say that 24% of all blue all M&Ms are blue, so we're going to take 24% of 820, and that gives us 196.8. Orange, they claim that 20% of all M&Ms are orange, so 20% of 820 gives us 164. And finally for green, they claim 16% of all M&Ms are green, so 16% of our sample of 820 would be 131.2. So all of these, each and every one of those is greater than or equal to 5. So all expected frequencies here are greater than or equal to 5. Again, CAP-N is not given, but I'm pretty sure that Mars Incorporated has probably made way more than 20 times 820 M&Ms. So it's safe to assume that that assumption is met, which means that the assumptions for the chi-square goodness of fit test Okay, that's my alarm that tells me I should be done with these things by now, but I'm not. All right, so assumptions for the chi-square goodness of fit test have been met. Okay, so again, we have one qualitative variable, color, and in this case it happens to have 6 categories, so not all chi-square goodness of fit tests need to have 6 categories, but our die happen to have 6 sides, and M&Ms happen to have 6 colors, but as we'll see in the homework, we can have any number of categories. All right, so step 4 says to find the test statistics. So using the calculator, okay, we would again put our observed frequencies in L1, and these expected ones that we just computed would go into L2. So then we're going to go into stat and move over test and then scroll down and find the chi-square goodness of fit test from the list, and then the setup for the test is in figure 11.2.6 below. Again, next to degrees of freedom, we are going to put a 5 again. But again, that's because our number of categories is 6 again. Number of categories of colors is 6. And 6 minus 1 is 5. Okay, so that degrees of freedom is always the number of categories minus 1. So again, it just so happens that the two examples in the book both have 6 categories, and so degrees of freedom happen to be 5. Okay, but degrees of freedom is not always 5. Okay, it depends on the number of categories given in the problem. All right, so our setup the same as the last problem. Again, we have different data now in L1 and L2. Degrees of freedom on this one again is 5 because we have 6 color categories. And so again, we would highlight calculate and hit enter. And again, on the output screen, we're only interested in the chi-square test statistic and the p-value. Degrees of freedom, important that it's entered incorrectly on the input screen, but we don't care about its value on the output screen. And the contributions, again, goes beyond the level of this course, so we're not going to be worried about those values either.